Assalamualaikum warahmatullahi wabarakatuh. In this video, I will discuss formative assessment moment distribution method for BIM. Okay, this is actually I am taking from group E assessment. Okay, last Monday. Okay, the first outcome that I need to actually to test is about the member stiffness factor. I want to know, are you able to calculate or to choose the member stiffness factor, the right formula for the member stiffness factor. So it is K stiffness, the symbol is K. So in moment distribution method, we usually use two formula to calculate K, and we need to consider far end condition. Okay, we need to consider far end condition. There are two far end condition. Okay, there are two far end condition. We have condition number 1. Okay, condition number 1 is called as far and fixed. And for far and fixed condition, we can also apply the same formula for internal support. Okay, this is number 1. Okay, for this condition, we will use K, which is equal to 4 EI over length of each element. Okay, so this is the formula. And for condition number 2, we have what we call as far and pin and rollers. And for far and pin or roller, we use K equal to 3 EI over L. 3 EI over L. So choose the right set of answer. Okay, KBC. Okay, we look at the diagram first. In the diagram, we have AB. B is internal, A is end fixed. So we use this 4 EI over L. And for member BC, since both B and C are actually internal support, so this one also we use 4 EI over L. And for member CD, okay, C is actually internal support, so that is what we call far end. So far end is actually referring to D. Okay, it is far end pin. So for far end pin we use, okay, for far end pin we use 3 EI over L. 3 EI over L. So the right answer is, okay, KBC 4 EI over L, KCD 3 EI over L. Okay, KBC 3 EI over L, this is wrong. Okay, this is wrong. This is wrong. KCD 3 EI over L, this is right. KAB 4 EI over L, this is right. KCD 4 EI over L is wrong. So the right answer is KBC is 4 EI over L and KCD is 3 EI over L. So the right answer is A. Okay, so we got 67% who choose the right answer. Okay, we move to, okay, still in the same outcome, member stiffness factor. Okay, now I ask you to calculate the K value using formula K is equal to 4EI over L for far end fixed and internal support, and for far end pin or roller we use 3EI over L. Okay, looking at the diagram, so K for AB, we have K for AB, we have K for BC, and we have K for CD. Okay, so K for AB, it is 4 divided by 2.8, and 4 divided by 2.8 EI is equal to 2.8. It is 4 divided by 2.8 is equal to 1.429 EI. Okay, for it is 1.429 EI. Okay, for KBC, so still need to use 4 divided by length is 3 meter EI. So this one we get 1.333 EI. And for KCD and pin, so we use 3. The length is 3 meter. It is EI, so this is equal to EI. So the right answer is KAB, we get 1.429 EI. KBC, we got 1.333. And KCD, we got 1. Okay, in terms of EI, of course. So for the answer A, KAB 1.429 correct. KCD is 1 EI. KCD. Okay, for B, KBC is 1.333. KBC is 1.333 and KCD is 1. Okay, and KBC, C, the answer C is KBC is 1.333. This is correct, and KCD is equivalent to, okay, wait. Okay, here we have 2 EI, so we need to consider whenever we calculate this, we need to time with 2, so we get 2 EI. So going back to this, okay, so this 2 is not correct. Okay, so KBC is 1.333 and KCD is equal to 2 EI. Okay, this is correct. So the answer is C. The answer is C. Okay, the answer is C. So 53% got the right answer. Okay, so for question like this, whenever the EI is not constant, whenever EI is not 1, it may be 2, it may be 3. So whenever we want to calculate K, so we have to time with the value. Okay, so we move to the next question. Okay, for this question, the outcome is to calculate distribution factor, DF. Okay, distribution factor. Okay, this question actually I just to know your understanding level. Okay, can you identify which n? Okay, which n we use distribution factor equal to 0, and which one we need to use distribution factor equivalent to 1. Okay, this actually refers to AND condition. AND condition means A and D, at A and at D. Okay, because B and C both are internal. So because in the answer we can see that I actually asked you to choose the distribution factor for A, B and DC, means that the AND condition, referring to AND condition only. Okay, distribution factor for A, B. Okay, distribution factor, there are actually two values. Okay, two values for AND condition. Number one, we will refer back to far and fixed or far and pin or roller. Okay, condition number one, far and fixed. For far and fixed, actually I have explained this concept, okay, in my previous video last week. Okay, for far and fixed, because the K value, because we get distribution factor from formula df equivalent to K divided by total K, and for n fixed, we have to divide by infinity. So that is why distribution factor for far and fixed is equal to 0. And for the second condition, it is far, in this case, far and pin. Okay, at D, far and pin. Okay, for far and pin, distribution factor is equivalent to K divided by total K. And this one is equivalent to 1. Why we get 1? Because distribution factor for AB, because A is fixed, it is equal to KAB divided by KAB per plus infinity. Because of this infinity, the value will be equal to 0. And for K, DF, for DC, it is actually KCD divided by KCD, because there's no member DE. Okay, the last is D. Okay, the last is member CD. So we get this. So that is why we get distribution factor for this case is equivalent to 1. Okay, so we can conclude that, okay, for 0 distribution factor, it is actually for fixed N, and the distribution factor which is equal to 1 is actually for pin N. Pin or roller N. Pin or roller N. Okay? Pin or roller N. Okay. So the answer is DFAB is 0. DFDC is 1. DFAB 0, correct. DFDC 0, this is wrong. Okay, DFAB 1, this is wrong. DFDC 1, this is correct. So the right answer is A. The right answer is A. Okay, let's see how many students choose the right answer. Okay, 86 students. 86% of students. Okay, so we move to the next question. Question number 4. For question number 4, okay, the same question. Choose the right set of answer. Okay, choose the right set of answer. Actually, all this is in term of choose the right set of answer. Okay, this is distribution factor. Okay, distribution factor for distribution factor. Okay, distribution factor, number of distribution factor in the question actually depend on how many n in the question, in the beam. How many n in the beam? If we have, if the beam, the question has 3 members. 3 members means there are 6 n. This is A, B, B, C, C, D. Okay, so one member has 2n. So how many members? There are 3 members. So 3 times 2 equivalent to 6. So there are 6n. So 6n, this 6 value representing number of n moment. Okay, representing what? Number 1, n moment. Member n moment. And number 2, number of distribution factor. Because we use distribution factor to calculate member n moment. Okay, we distribute joint moment, we get member n moment. How to distribute? The joint moment we times with distribution factor. Okay, so there are 6n. So from this we know that there are this DFAB. Okay, DFAB we get from MAB. DFBA we get from MBA. We get 4 MBA. We have we have MBC. Okay, for DFBC, and then we have MCB for DFCB, MCD, DFCD, MDC, DFDC. Okay, so for the distribution factor, we have actually calculated just now that NADF for NA is equal to 0 and DF for D equivalent to 1. Now we have 4 remaining value of distribution factor, okay, to be determined. So we calculate this from K. Okay, we calculate this from K because distribution factor, the formula is K divided by total K. And if we refer back to this, okay, the previous question, K, okay, it is 1.429, 1.333 and 2. This is 1.429, 1.333, this is 2 EI. So all this in terms of EI. Okay, in terms of EI. So to calculate distribution factor for BA, so distribution factor DF for BA, it is equal to 1.429 divided by 1.429 plus 1.333. Okay, and the answer is 1.429 divided by 1.429 plus 1.333. This is equal to 0.517. 0.517. Okay, doesn't matter. Okay, 0.517. This is 0.517, and actually for internal support, the total must equal to 1, means that K for B must be equal to 1. So since we have actually determined BA, so we will get DFBC, which is equal to 1 minus 0.517, and this is equal to 0.517 483. 0.483. 0.483. Okay. Okay, so we move to C. Join C. We have CB and CD. CB and CD, we have for CB, we have 1.333 divide by 1.333 plus 2. Okay, this one we get 0.4. So remaining 0.6. Because total this must equal to 1. Total this also must equal to 1. Okay. And this is also equal to 1. Except fixed n. Fixed n distribution factor equal to 0. Okay, now we check back the right answer. Okay, so DFCB 0.4, DFCB 0.4, that is correct. This is correct. DFCD 0.6, DFCD 0.6, so this is 0.6. This is also correct. DFBA is 0.517. This is correct. DFBC is 0.483. 0.483. Okay, DFCB, CB is 0.4. DFBC okay, DFBC, wait, where is it? The FBC, this is correct, 0.4 CB. The FBC is actually BBC. BC is equal to 0.483, not 0.517. So we have here two right answer, A and B. Okay, so next. Okay, so question number 5, this is actually very general question about moment distribution method. So actually I am asking you to choose, okay, more than one answer. So what actually we do whenever we want to use moment distribution method to analyze, okay, to analyze the goal. The goal is of course the goal to calculate, to use moment distribution method is to calculate member and moment. And member and moment is actually known, it is actually can also be called as internal moment at each end. So B is also right answer, C is also right answer. So do we need to calculate fixed end moment in the moment distribution method? The answer is yes. We need to calculate fixed end moment because fixed end moment is actually the first member and moment in the distribution table. So A is also correct. Okay, do we calculate distribution factor? Of course, yes, we calculate distribution factors. We calculate distribution factors from stiffness factor. And stiffness factor, do we calculate stiffness factor in moment distribution method? The answer is also yes. So for this question, all is actually the right answer. Okay, all is actually the right answer. So this is the result. So congratulations. Okay, so maybe in the next video I will discuss the other group. Okay, the other group assessment, because So every group I actually gave different diagram. Okay, so thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.